This is an interesting problem for describing removable and non-removable discontinuity. So first of all, let's factor the top and bottom. So this function, if you factor the top, you have x times x minus phi, and then the bottom, factor that into two factors. So that is x minus phi and then x plus 1. So negative 5 times 1 is negative 5, and then negative 5 plus 1 is negative 4. And then what can be removed? So the answer is x minus 5 can be removed, right? So as a result, you have x divided by x plus 1. Then where is the removable and non-removable discontinuity? So the removable discontinuity is x equals to 5, because we can do algebra to get rid of it. What about non-removable? So non-removable discontinuity is x equals to negative 1. So when x is equals to negative 1, we have a 0 in the denominator, but this cannot be removed. So we call this non-removable discontinuity. How about the limit? So what happens when x approaches to negative 1? So what happened limit as x approaches to negative 1, x divided by x plus 1. What happened? So this one you have the top, so you have a negative value, right? So you have a negative number and then divided by what's in the bottom. So negative 1, so we have a number that is a little bit less than negative 1. So for example, x is equals to negative 1.00001, and then you take that, you add 1 to it. What is that going to be equal to? So you take that, you add 1 to it, so that is equal to 0.00001, right? So you take a negative value divided by that. What's the answer going to be equal to? Oh, forgot the negative. You take a negative divided by negative, you get a positive, right? So if you take any negative value, so let's say negative 5, you divide it by that, you get a pretty big value, right? So if you make many zero between the decimal point and a 1, that means you are taking a number that is so close to negative 1 on the left hand side. I forgot to draw the left, so let's say like this. And then you take that plus 1, you take a negative value divided by that, you are going to get a positive infinity. So as a result, this is equals to positive infinity. And then what about right hand side? Limit as x approaches to negative 1 from the right, x divided by x plus 1. So this one you can think about this. So negative 1, so how about negative 0.9999. This is close to negative 1 and is a little bit greater than negative 1. So if you take this number and then you add 1 to it, what's going to happen? You get 0.0001, right? And then you take a negative value, so you take a negative value divided by 0.0001. As a result, you will get a much bigger value. So if you pick a number that is just a little bit, tiny little bit greater than negative 1, and then you add 1 to it, that means you are having many zero between the decimal point and a 1. You take a negative number divided by that, you will get a negative infinity. All right, so you will get a negative infinity. So what is the graph look like? What are we trying to graph? Are we trying to graph the x squared, or we are trying to graph the x divided by x plus 1? So when you do a graph, you are graphing x divided by x plus 1. What is the graph look like? The graph looks like this. Let me sketch this using another color. So first of all, we sketch our x-axis, and then we sketch our y-axis. Where is the non-removable? The non-removable is x equals to negative 1. Okay, let's sketch that. So x is equals to negative 1. So when x is equals to negative 1, that is non-removable. So negative 1. All right, so what about the removable? The removable is x equals to 5. So when x is equals to 5, we have 5 divided by 5 plus 1. So we have 5 divided by 6. That is approximately equal to 0.8 0.83 approximately equals to 0.83. So when x is equals to 5, let's say 5 right here, so we have 0.83, so 0.83, and then this is a removable, right? That means we will be using an open circle. As x approaches to -1 from the left, y goes to positive infinity. So as x approaches to -1 from the left, y goes to positive infinity. As x approaches to -1 from the right, y approaches to negative infinity. So let me use another color to give you a better contrast. So as x approaches to -1 from the left, y goes to positive infinity. That is this piece. As x approaches to -1 from the right, y goes all the way down to negative infinity, and then you will get this piece. And then of course there is a horizontal asymptote, but don't worry about that. So after you are done, the graph looks like this. So we have a non-removable at x equals to -1, a removable at x equals to 5. So what's the difference? The difference is for non-removable, you use a vertical asymptote. So this is a vertical asymptote. And then for removable, then this will be just an open circle, as you see right over there. So you don't have a vertical asymptote for removable discontinuity. Alright, so that is the end of this video. If you think my instruction is helpful and clear, let me know in the comment below. Like the video, share the video for me. Subscribe to my channel if you are on your way out. I will catch you all in the next one. Signing off for now.